Welcome to The Foundry by Forge College. Today, we are talking about testing and maintaining whitelists. Right off the bat, take a look at the image on your screen. A velvet rope and a clipboard. That is exactly the mental model you need for this topic. In our previous lesson on designing real-time analysis and alerting, we basically set up the security cameras for our network. Today, as part of the Applied Solidity development track, we are walking right down to the front door to secure the entrance. Think of a smart contract whitelist as the bouncer's clipboard at an exclusive club. It's the master record that decides who has been pre-cleared to enter based on their ID and paperwork and who has to wait out in the cold. If your list is broken, things get messy quickly. Random people walking by could rewrite your entry rules. Your actual approved VIPs get locked out. Before you know it, you have total gridlock at the front door. Launching a multi-million-dollar token sale without rigorously testing those entry rules is like handing a blank piece of paper to a blindfolded bouncer. You guarantee the event is ruined before the first guest even arrives. There are two primary ways people get into our club. We can write down one single name on the list, or we can open the doors for a massive 30-person VIP entourage all at once. Let's look at this logic flowchart. This represents our single update test. To prove the door works for one person, the test has to verify two distinct things. First, the wallet address actually gets marked as approved. That's the green checkmark you see. Second, the system has to shout out to the rest of the club that someone entered, which is that KYC updated event popping out. Now watch the diagram expand to handle the entourage. This is a batch update. Instead of doing things one by one, the smart contract uses a loop to process a large group of addresses simultaneously. You can see the blocks turning green sequentially as the loop runs. But notice what happens at the end of the line here. The loop processes 9 blocks perfectly, but shuts down and leaves the 10th block stranded outside with an X. This is the notorious off by 1 error. It happens when the code accidentally tells the loop to stop counting one step too early. To fix this, we write a specific test rule. We instruct the test to count the exact number of approval events that get emitted and verify that it perfectly matches the size of the original entourage. If 10 people show up, we need exactly 10 approval events. By mathematically proving your batch updates work under a microscope, you ensure that the scripts running later on won't accidentally hand out tokens to someone stuck outside the club. Knowing how people get on the list is great, but we also need to strictly control who is allowed to hold the clipboard. These access control concepts are things we dive into extensively in our Forge College courses because they are common targets for exploits. Look at this interaction on screen. This is a non-admin call test. We're simulating a random person trying to grab the purple admin clipboard to change the rules. The test specifically checks that they get bounced immediately, triggering that massive revert stamp. We also have to test for traffic jams. What happens if the club manager tries to update the rules twice in the same millisecond? That creates a race condition, where the code trips over itself processing overlapping commands. To keep these tests from getting tangled up, we start from scratch every single time. By deploying a fresh, isolated copy of the club entrance for every test, we ensure that the results are predictable and weren't influenced by whoever tried to get in 5 minutes ago. As you run these tests, you maintain a debug report. Think of this as the manager's permanent logbook. It follows a strict 4-step workflow. Capture the error, hypothesize the cause, fix the code, and validate the solution. Inside that report, you don't just write down "it broke." You paste the exact console outputs and the raw stack traces. You leave a precise paper trail proving exactly how a bug was squashed. While the code handles the front door, the debug report provides the proof auditors need to trust that your entrance rules are rock solid and reliable under pressure. As the diagram shows, the whitelist slides right into place as the essential first gear in the much larger machine that handles your token distribution. By rigorously testing those single updates, counting the batch arrays, locking down the admin rules, and logging every fix in your report, you transform a risky block of code into an auditable, rock-solid VIP list. You need that stability for what comes next. In our next lesson, Survey of Vesting Types and Beneficiaries, we will look at complex token lockup schedules. You absolutely cannot build those schedules until you trust the whitelist feeding them. the path to mastering smart contracts is all about building these verifiable layers. To learn more about testing, debug reports, and continue your Web3 education, head over to forge.college and explore our resources. Keep building, and we'll see you in the next lesson.